So welcome all of you for the advanced technical training sessions from our department and our institute. We have started for the advanced technical sessions, and for that today we are going to start for the hydraulic engineering, and from the hydraulic engineering we are going to start for the dimensional analysis and hydraulic similitude. So today's topic for the discussion is about the dimensional analysis and hydraulic similitude, in which what we are going to discuss, we are going to discuss about the firstly the basics fundamentals of the dimensional analysis and hydraulic similitude, and after that we are going to start for the discussion of the directly the questions those were asked in the gate examination and the Indian engineering services examinations. Okay, so without wasting time we'll proceed further. Firstly, we'll go for the syllabi of the GATE 2021 for the hydraulic engineering. So mostly I'm focusing here about the hydraulic engineering syllabus, which is there for the GATE 2021. It includes the hydraulics. It is about the forces on immersed bodies, flow measurement in the channels and the pipes, dimensional analysis and hydraulic similitude. Then channel hydraulics, it includes the open channel flow, which contains the energy depth relationships, specific energy, critical flow, hydraulic jump, uniform flow, gradually varied flow, and water surface profiles. Okay, from that from all of whole this syllabus, today we are going to discuss about the dimensional analysis and hydraulic similitude. So firstly, what I would like to do, I would like to go for the basics of the dimensional analysis. Okay, before proceeding to the non-dimensional numbers and their significance, I would like to go for the Buckingham Pi theorem and other things. So without going into the depth, I would like to go for basics directly. So those you have studied in the regular sessions also, and I would like to help whenever required to get into basic things related to the which we are going to discuss now. So first and most important point, that is a dimension. So what is meant by a dimension? Quickly, I want to have an answers from your side. What is meant by a dimension? Firstly, dimension यानी कि क्या होता है? Anyone? Dimension, unit, then fundamental units, fundamental dimensions. That whole part we have discussed in the previous sessions also. So first point I want to know about from your side, that is what is meant by a dimension. What is meant by unit? And the units, or what trying to say the that dimension or that particular dimension is a fundamental or a derived. कब बोलोगे आप? Unit यानी कि क्या रहता है? What do you mean by a unit? Unit is nothing but the standard of measurement of the physical quantities. It is nothing but the unit. And dimension is nothing but the any measurable extent. That is nothing but the dimension. For example, length is one of the dimension. Length is one of the dimensions. So if you consider once again and any object, suppose that this is an object. So here I have drawn in a 2D, two-dimensional. So it will have the length and the height also. So it is having the dimensions for a length and dimension as a height. And if you are going to start the measurement of this length from one end to the another end, that is from the one end to the another end in a fixed direction, we can say, then this particular thing will be nothing but our dimension. Means if you are going to measure the length of this object in a particular direction, then in that case it becomes the dimension of that particular object. This is about the dimension. Then the next fundamental thing is about the unit. So unit is nothing but the standard of measurement of the physical quantities, or standard of measurement of the dimensions. So whenever you are going to measure a length here, then the length will be measured in some of the standards of the measurement. For example, that standard of measurement will be the meter, maybe the centimeter, maybe the inch, maybe the millimeter, etc., etc. So the meter is nothing but the unit of the dimension length. यानी कि लेंथ जो डायमेंशन है उसका जो यूनिट है वो रहेगा मीटर, नहीं तो सेंटीमीटर, नहीं तो मिलीमीटर. So unit is nothing but standard of measurement of a physical quantity or standard of measurement of a dimension. That is a unit. Then the standard units or the standard dimensions and derived units or derived dimensions. The standard unit is that unit which is independent on the units of the other physical quantities. It means that it is also called as a fundamental unit, or it is also called as a primary unit also. That primary unit or the fundamental unit is that unit which is independent on the other physical quantities. For example, meter. So meter is independent on the or it is dependent only on the measurement of the length, or a measurement of the height, or a measurement of the depth. It means that whenever you are going to measure a length, whenever you are going to measure a length, we will have its unit as a meter. Only one we can say, only one dimension we can say. Here for the length, unit is a meter. Similarly, for the height, again the unit is a meter or a centimeter or a millimeter. Or if you want to measure a depth of the well or a bore well or anything else, then in that case we are having its unit as a meter. It is not dependent on the other dimensions. It is directly dependent upon the how much length you have measured, how much height you have measured, or how much depth you have measured. So if that unit is independent on the other physical quantities, or if the unit is a concerned with the only one physical quantity, in that case we can say that that unit is a fundamental unit, or a standard unit, or we can say a primary unit. Standard unit we can't say all the times. Instead of talking, or instead of considering as a standard unit, I would like to consider as a fundamental or the primary. So fundamental or the primary is independent on the number of physical quantities. It is dependent on only, or it is concerned to the only one dimension we can say. It is for a length as a meter. Then the second type, that is derived or a secondary. Derived unit, okay, it is also called as a derived unit. So derived unit यानी कि क्या रहेगा? So derived unit is that unit which is dependent on the units of the number of physical quantities or number of dimensions we can say. For example, the unit of area. Unit of area, for example, for this case, if you consider it as a rectangle or a square, then its area will be square of the length. It will be square of the length into width, or length into height here, length into height. So length is having unit as meter, and again the height is having unit as a meter. Means for getting the unit of the area, which will be a square meter, meter into meter as a meter square, which is a square meter we can say. So here for getting the unit of the area, we require to go for the unit of the length and unit of the height also. And by taking those units into consideration, we got the unit of the area. But for getting the unit of the length, we were dependent only, or we are dependent here only on the unit of the length. In that case, that unit is called as a fundamental or a primary. This is nothing but the fundamental or a primary unit, whereas this square meter is nothing but the derived or a secondary. Derived because we have derived it from the unit of the length and unit of the height. That's why we are considering here as this unit of the area is a derived unit. Similarly, if you go for the volume, consider a volume of a cuboid, then it will be given as a length, product of length, width, and a height. So once again, length will be measured in meters, width will be in a meter, and height will be once again in a meters. It means for getting the unit of the volume, we will be required to know about the unit of the length, unit of the width, and unit of the height, and that will be a meter cube. Means this is a dependent on the unit of the length, unit of the width, and unit of the height. Means it is dependent on the three physical quantities: length, width, and height. Okay, so that's why we're considering here as the unit of the volume as a derived unit, that is meter cube. So this is about the fundamental units and derived units. Other parameters are also existing. I'm not going into the depth of that. Okay, then from the dimensions of all the such parameters, that is a length, width, height, temperature, velocity, acceleration, etc., etc., those dimensions are derived from the units of those physical quantities. For example, if you consider the physical quantity as an area which we have considered here, then we have to go for the dimension of that. We have to go for the dimension of that. So dimension in the sense what? We have to uh, notify, or we have to put forth here the it's a fundamental form, यानी कि जो भी उसका डायमेंशंस आएंगे, यानी कि एरिया के डायमेंशंस क्या क्या आएंगे यहाँ पे, लेंथ और हाइट उसका डायमेंशन आएगा. It means we will be required to measure the length and height as a physical quantities. It means we will get it's a dimension in terms of the length and height. We are knowing that the fundamental dimensions are a LMT, length, then mass, and a time. So those three are the fundamental dimensions. Okay, and whenever we used to mark them, or whenever we used to put for them in a square bracket, in that case we used to consider it's a dimensional form. So similarly, for the area, if you want to go for a dimensional form, then firstly we have to check what is its unit. So unit for the area we have considered here as a square meter. We have unit as a square meter, and at square meter unit is a having it is composed of the dimension length and height. It means if you consider here as a this one as a B, C and D, then AB is a length, then BC, though we are saying it has a height, but we can say it is a length parameter, another length parameter. Okay, it means that this square meter will have the dimension as a L square. How come I'm writing here as a L square? Because unit of the area is a square meter, and square meter is a composed of here the unit of length and a height, that is marked here AB as a length and BC as a height. But we can consider here the BC as also one of the height parameter, and a CD as also another height parameter, sorry, length parameter, and a DA also as another length parameter. It means that here we can represent the L into a L, that is a L square. Here mass is not involved, time is not involved, so we can write here the dimension of the area as a L square. Similarly, for the volume, if you go for the dimension form, then it will be L cube. It will be L cube. Similarly, if you go for the another one, that is a velocity, then velocity we are knowing it's a unit as a meter per second, and meter is once again a unit of a length, and second is a unit of a time. Okay, so it is nothing but, or it will be having the dimensional form as length raised to 1, okay, or a simply L if you write, then also it works. Then time t, but it is in a denominator, so if you take in a numerator, it will be raised to a -1. It means L raised to 1, t raised to -1 will be the dimension of the velocity. Similarly, another one I'd like to go for acceleration. Acceleration is having unit as a meter per second square, means length upon square of the time. Okay, that will be as a L raised to 1 and t raised to -2. So like this we are generating the dimensions of the various physical quantities, various physical parameters, or physical quantities we can say directly. So out of considering all the physical quantities, that is the length, area, volume, angle, time, mass, force, viscosity, acceleration, etc., etc., all those dimensions, or all those physical quantities we can say, firstly, all those physical quantities are grouped into the 3 categories. So first one is the geometric category, second one is kinematic category, and third one is a dynamic category. So geometric category means the fundamental, sorry, the physical quantities, those are governing about the geometric things related to that a particular object or a phenomenon are grouped into the geometric category. So which are those? So under a geometric, length is there, okay, then area is there, volume is there, angle theta is there. Those are related to the geometric properties, geometric quantities we can say. Second group is about the kinematic. So kinematic group involves or includes the properties related to the velocity, acceleration, etc. That is first one I would like to go for velocity. acceleration, then time will be there, it is related to the kinematic thing. Acceleration will be angular acceleration, linear acceleration, then gravitational acceleration is there, g, then discharge q is there because it is meter cube per second, okay, which involves a velocity parameter. Then kinematic viscosity, that is mu, is also there in the kinematic group. And third group is about the dynamic group. So dynamic group involves or includes the all the physical quantities those are related to the force, various forces acting on a flowing fluid, for example. And also along with that, we will resume now. Along with the various forces, it includes the causes of the forces also. It means it includes the mass, okay, then force, then weight, okay, then specific weight, pressure intensity, then dynamic viscosity, that is a mu. All those are grouped under the dynamic physical properties, and out of them the length, mass and time are considered as a fundamental dimensions or fundamental physical quantities, that is L, M and T. I'm moving hurriedly because already we have seen that part, and I'm just going into the concept of that, and after that we are going to discuss the examples or the various multiple choice questions those were asked in the GATE and the ISE. Okay, this is about the basics about the grouping and the dimensions and the fundamental things. The next thing is that why to go for a dimensional analysis and what are the various methods of the dimensional analysis. So firstly, that a dimensional analysis is nothing but the formation of the various groups of the various physical quantities, okay, so that we will get an meaningful combination. For example, we used to write Q is equals to AV. We used to write the discharge equation as a into the V. This is nothing but the combination of the area, one of the physical quantity, and another one is a velocity, another physical quantity. If you go for the combination of the area and velocity, we used to get directly a discharge. How come we used to write that? We used to get the help of the dimensions involved here. So for example, we are considering a discharge, then discharge is having unit as a meter cube per second, whereas unit of area is a square meter and unit of the velocity as a meter per second. Means here if you consider the dimensional form, then meter cube per second is equals to the meter cube per second. Both the quantities those are there on the left hand side and on the right hand side are having the same units, that is meter cube per second, meter cube per second. And again you will go for the dimensions of related to that, they will be the one and same. For example, for meter cube, the dimension is a L, it's a cube is there, so L cube, and T will have the dimension as a raised to -1 because it is in a denominator. Similarly for this side also, meter cube is there, so it is L cube and T raised to a -1. It means that by taking the help of the units and the dimensions, we are able to derive the various equations. We are able to find out the various combinations of the physical quantities so that we will get a meaningful combination. This is an application of the dimensional analysis, we can say. So how to proceed for that? How to get that combination? That is exactly Q is equals to AV, as we are knowing that. So like that's why I'm writing here as a Q is equals to AV. But if you want to go for a new equation, new combination, then for that purpose, we need to go for a dimensional analysis. And for getting the dimensional analysis, the tools, the various things those are available, those are put forth by various researchers. And it's mainly two dimensional analysis methods are there in. Those are the Rilling's method and the Buckingham Pi method. Most of the times we used to prefer for the Buckingham Pi method. So what is that Buckingham Pi method? So Buckingham Pi method says that if there are n variables, if there are total n variables involved in a particular physical phenomenon, and out of that total n physical phenomenon, total n number of total n number of fundamental dimensions, total n number of variables. Suppose that n number of variables are length is there, mass is there, temperature is there, time is there, velocity is there, acceleration is there, etc., etc. Viscosity is there, discharge is there, etc., etc. Parameters are involved. Those parameters were considered as a n number of parameters. Ye from all those n number of parameters, after putting their dimensions, but that is by putting the dimension of length, mass, time, temperature, velocity, acceleration, those are involved in this particular phenomenon. If we are getting m number of physical or fundamental dimensions, are three fundamental dimensions are there, that is L, M, T. Means out of these n variables, if those n variables contains the m fundamental dimensions, then we can group or we can arrange those n number of parameters into the n minus m number of non-dimensional groups. Then we will be able to, or we are going to adjust them, or we are going to group them into the n minus m number of non-dimensional groups or non-dimensional parameters. Those parameters are considered as a pi parameters. Means number of pi terms, those we will be possible to form out of available n variables containing m fundamental variables will be n minus m. It means suppose that time being we have a number of parameters involved in a physical phenomenon. Say the physical phenomenon of a aircraft which is a crashing. In that, suppose that total number of variables those are involved are 20, and out of those 20 variables, the number of available or number of physical quantities those are included therein are 3. That is a m is equals to 3, we can say. Then this total 20 number of parameters we will be able to arrange into the non-dimensional groups, that is called as a pi groups, will be equals to n minus m. That is equals to n as a 20 for this case and the m as a 3. Means we will be able to arrange those 20 number of variables into 17 number of non-dimensional groups, and those non-dimensional groups are called as a pi groups or pi terms. This is the basic of the Buckingham's pi theorem. Okay, and then while selecting this while forming those pi terms, that is a 17 pi terms we want to have out of available 20 fundamental 20 number of the variables those are involved in that particular phenomenon of a crashing of the aircraft. We don't know how many are there in, but we have considered as a 20 phenomena are there, physical parameters are there in, and out of that 3 are having 3 fundamental dimensions are there. Means we will be able to group those 20 number of parameters into the 17 number of non-dimensional groups, non-dimensional parameters we can say. That is a pi 1 to pi 17 we can say. So I would like to write here. So number of pi terms those we will be able to form are pi 1 to the pi 17. So total किती असणार आहे तिथं? टोटल 17 पाय टर्म्स आपण तयार करू शकतो. आणि पाय टर्म म्हणजे काय असते की नॉन डायमेन्शनल ग्रुप असतो, तो नॉन डायमेन्शनल पॅरामीटर होतो. इट इज टू हॅव अ 0 dimensions, that is L0, M0 and T0 we can say, non-dimensional parameters. So while arranging those pi terms from the available 20 parameters, we need to arrange all those 20 parameters in such a way that there will be repeating variables, in such a way that there will be the repeating variables. Now repeating variables यानी कि क्या रहेगा, जो भी आपके पास 3 fundamental parameters आपको मिल रहे हैं, those 3 parameters must be get involved in those repeating variables. जो भी आपके पास repeating variables रहेंगे, so repeating variables में क्या क्या आना चाहिए आपका, एक तो आपका ज्योमेट्रिक पैरामीटर आना चाहिए, दूसरा काइनेमेटिक प्रॉपर्टी उसने रिप्रेजेंट करनी चाहिए, और थर्ड वाले ने डायनामिक प्रॉपर्टीज रिप्रेजेंट करनी चाहिए. यानी कि जो भी आपके टोटल 20 नंबर ऑफ वेरिएबल्स है, उसमें से जो आप 3 वेरिएबल्स सिलेक्ट कर रहे हैं, जो आपके रिपीटिंग रहेंगे यहाँ पे, मिनिमम 3 आई एम टॉकिंग अबाउट, ओके, उसमें से एक ने ज्योमेट्रिक प्रॉपर्टी रिप्रेजेंट करनी चाहिए, दैट मे बी द लेंथ, एरिया, वेलोसिटी, एंगल एक्सेट्रा. दूसरे ने काइनेमेटिक प्रॉपर्टी रिप्रेजेंट करनी चाहिए, that may be velocity, acceleration, dynamic viscosity, kinematic viscosity, etc. And third one must represent the dynamic property, that is a mass, then dynamic viscosity, then force, weight, pressure, intensity, etc., etc. It means those three repeating variables, we have to select those three repeating variables which are going to appear in each and every pi term. And for them, the selecting parameters or selecting criteria is that each parameter must contain the either geometric or kinematic or the dynamic property. Next criterion is that those repeating variables must not be the dependent variables. Those repeating variables must not be the dependent variables. Means suppose that here during an crashing of the aircraft, we are considering the force of a crushing, we can say crashing. In that case, the force must not be the repeating variable because this is a dependent on the other parameters. Okay, it means all the parameters, those out of which we are going to consider as repeating variables, those repeating variable must be an independent variable. And next characteristic, which is the most important, that is after selecting those repeating variables, there is a three repeating variables which we are going to consider. They should not to form any non-dimensional parameter there. यानी कि जो भी हम तीन repeating variables consider करेंगे यहाँ पे, वो they must not form any non-dimensional group amongst themselves. This is the criterion for the selection of the repeating variables. Okay, so this is about the dimensions, unit, then what is meant by dimensional analysis, and the Buckingham pi theorem, and how to select the repeating variables. Okay, now with respect to this part, the whatever the questions those will get asked in a gate examination, we'll go for them now. हा याच्यामधला जो आपण पार्ट डिस्कस केलेला आहे त्याच्यावरती जास्तीत जास्त जे आजपर्यंत जे विचारले गेलेले जे गेट मध्ये जे क्वेश्चन्स आहेत ते म्हणजे की रिपीटिंग व्हेरिएबल तुम्ही कसं कन्सिडर करणार, सिलेक्ट करणार. तुमच्याकडे एवढे एवढे पॅरामीटर्स आहेत टोटल आणि त्याच्यामध्ये एवढ्या एवढ्या फंडामेंटल डायमेन्शन्स आहेत, तर तुम्ही त्याच्यामधनं किती नंबर ऑफ पाय टर्म्स तुम्ही कन्सिडर करू शकणार ते तुम्हाला विचारलं जातं. ओके, त्याच्यामधला मी जो पहिला घेतोय क्वेश्चन तो 1994 ला विचारलेला आहे, 1990. The first example related to the top points those we have covered in previous slides. It is about the finding the number of pi terms involved. It was asked in a GATE 1994. I'd like to write here. It was asked in a GATE examination of 1994 for 1 mark. Okay, weightage for of a question was 1 mark. But they asked the number of pi terms needed to express the function f as a function of area, velocity, time, viscosity, and length is equals to 0 r. The options they had given us: A as a 5, second option B as a 4, third option as a 3, and a last option D as a 2. So how many pi terms will we get formed to express this functional relationship? That was the question they had asked. So how many pi terms will be there? How to find out the pi terms? First step is that we have to firstly mark number of available variables or number of total involved variables here. So I would like to go for number of variables, small n. So how many variables are involved in this particular phenomenon? How many are there?
5.
5. Area, velocity, time, viscosity, and length. So n is equals to 5. Okay, then number of fundamental dimensions. Number of fundamental dimensions, it means it will be required to go for the writing the dimensions here. So for area, we are knowing dimensions. I would like to go for area is having the dimension as a square meter. I would like to write the dimensions for toward this side. Area is having unit as a square meter, so its dimension will be L square. Then velocity is having unit as meter per second, so dimension will be L raised to 1 and T raised to -1. Then time T is there, so time T is having unit as a seconds, so it will have the dimension as a T only. Okay, then after that, the next one is the length and the viscosity. So firstly, we'll go for the dynamic viscosity mu. So for dynamic viscosity mu, we are knowing its a unit as a Newton second per meter square. Newton second per meter square. Newton is nothing but the kg meter per second square. So directly I would like to go for its dimensions. That is a m1 mass is there. Then L raised to -1 and T raised to -1. This is for the mu. And lastly, the length. So length will have the dimension as a L only. It is having unit as a meter and its a dimension will be the L. Now, from the dimensions, those who have written here, how many fundamental dimensions are there? So fundamental dimensions are L, M, and T. Fundamental dimensions are L, M, and T. I would like to write here fundamental dimensions L, M, T. So is all three dimensions are there here? Yeah, only length is there. Yeah, only mass is there. Yeah, only T is there. Yeah, any two are there. By looking towards the dimensions, those I have written over here, how many dimensions you are finding as a physical dimensions? L, M, T जो हमारे फंडामेंटल डायमेंशंस है वो तीनों है इसमें या कोई एक है या कोई दो है?
सर तिन्ही पण आहेत.
All three are there. If you go for the first one, area, it is having a length, one is there, means here one fundamental dimension we can say. Velocity, it is having L and T, both are there. In time is having a T, means if you consider one A and T, then two fundamental dimensions we can say. Then we'll go for the mu, it is having M, L, T, all three are there, and lastly L is there. It means we can write here the number of fundamental dimensions available here are 3. So number of pi terms will be now, how many pi terms we will be able to form here for this case?
2.
Total number of variables are 5. Out of that, 3 fundamental dimensions are available with us. Then how many pi terms we will be able to form here or will be required to express this functional relationship? So how is to write? The pi terms will be equals to n minus m. So n is equals to 5 minus m is a 3. So how much? What is the answer?
2.
2.
So correct option will be now
Option D.
option D will be the correct option for this particular question. This is the correct answer. That is 2 pi terms will be required to completely define or to express this functional relationship. Okay. Now the next question related to the same. I will read the question. The repeating variables in a dimensional analysis should. I would have to go for question also. It was asked in 1996 in the GATE examination of 1996 for 1 mark. But they asked it is related to the repeating variable. The repeating variable in dimensional analysis, the repeating variables in a dimensional analysis, I'd like to go for a short form here, should be, or should we can say. They had given us the options as first option is should include the dependent variable, include dependent variable. Okay. Then second option is have amongst themselves all the basic dimensions, have all basic dimensions. I'm using a short form here, basic dimensions amongst themselves, यानी कि जो भी हम लेने वाले हैं यहाँ पे, they should have an all the basic dimensions amongst themselves. C option is be derivable from one another. should be derivable from one another, यानी कि जो भी हम कंसिडर करने वाले हैं एक दूसरे से हमें डिराइव कर सकेंगे, लाइक वाज दैट. एंड लास्ट ऑप्शन इज exclude one of the basic dimension, exclude one of the basic dimension. So go through the question and you tell me the answer. I got the answer as a B from some of you. Okay, how come that also we have to go for? Question क्या है? The repeating variables, or for the repeating variables in a dimensional analysis should, options are include dependent variable, have all basic dimensions amongst themselves, then they should derivable from one another, then next one is the exclude one of the basic dimension. So in the previous part we have discussed about the selection of the repeating variables. In that the criterion we have discussed, that criterion says that the repeating variable should not to form any non-dimensional parameter amongst themselves. Okay, then it means the next one is they should not, the repeating variable must not be the dependent variable, means the first option gone over here, it is not applicable. Then they should not be they should contain all the fundamental dimensions, okay, including them, यानी कि जो भी हम रिपीटिंग वेरिएबल्स लेने वाले हैं, मान लो कि 3 लेने वाले, 4 लेने वाले, 5 लेने वाले, जितने भी लेने वाले हैं, जो भी हम नंबर ऑफ रिपीटिंग वेरिएबल्स लेने वाले हैं, उसमें क्या होना चाहिए, ऑल 3 फंडामेंटल डायमेंशंस मस्ट बी देयर, और एटलीस्ट 2 फंडामेंटल डायमेंशंस मस्ट बी देयर. इट मींस द सेकंड ऑप्शन आई एम फाइंडिंग एज अ somewhat appropriate here. Then third one is derivable from one another. If they are derivable from one another, then it will not be a non-dimensional parameter, so this is also not applicable. And last one, exclude one of the basic dimension, यानी कि जो भी हमारे basic dimensions है LMT, उसमें से एक dimension नहीं होना चाहिए, so this is also and not applicable, because they should have or they should include all the fundamental dimension. It means the correct answer for this is option B, that is they should have the all the basic dimensions amongst the themselves. Okay, this is related to the example question which was asked in a 1996 GATE examination. Then this was related to the Buckingham pi theorem and selection of the repeating variables. Now we'll go for the next parameters. That is a next part we can say related to the dimensional analysis and homogeneity. Okay, the next part. Before proceeding to the next one, I would like to go for the question related to the dimensional analysis, which was asked in Indian Engineering Services in 2017. Okay, what they had given, which of the following factors are a non-dimensional factors? Question is, out of the following factors, what are the non-dimensional factors? Okay, option one they had given us here. Just a minute, I would like to go for the options firstly here, so that you will be in the position to answer the question. First option is the changes constant. Option A is a changes constant C. Second one is a measure of the sublayer. (11.6) as a measure of sublayer. Short form मध्ये लिहितो मी, measure of a sublayer. Third one, they had given us a ratio. It is H, that is a head, divided by n square d square, employed in comparing the performance of the pumps. Okay, if you are remembering, then you will be in the position to identify what is to say it. Okay, then next option, this was the C. D, they had given the numbers. Okay, we'll go for numbers. 1, 2, 3. Fourth number is a Q square. divided by d raised to 5, which is employed in a computations in a pipe networks. Okay, and the last option, that is a fifth one they had given us, that is a u divided by root gl, u divided by root of a gl, used in estimating a wave making drag force. Okay, they out of that they had given us the options. Now they are the, this is the related to the question, the options those are asked, those are given, that is for selection of the correct one. First option is a 2 and 5. Second option is a 2, 4 and 5. Third option C, that is a 1 and 5. And last option D is a 1, 3 and 4. What they asked here, they asked which of the following factors are a non-dimensional. First one is changes constant. Second one is a 11.6 as a measure of the sublayer. 11.6 is a number as a measure of sublayer. Third one is h by n square d square, which is employed in comparing performance of the pumps. Then fourth one is q square by d raised to 5, employed in computations in pipe networks. And the last one is mu by root gl, which is used in estimating a wave making drag. Okay, out of that we have to select the non-dimensional groups. They have given options as, first option as 2 and 5, 2, 4, 5, 1 and 5, 1, 3 and 4. So which option is the correct one as per as the non-dimensional groups are concerned? I would like to go for non-dimensional group or non-dimensional factors. I would like to go for from the given variables, given parameters. It was asked in ESE 2017. Anyone? Which are the non-dimensional parameters here from the given parameters? Firstly, I would like to go for the answer and then I would like to go for the explanation over that. So correct option is here as a option A, that is a 2 and 5, means this one, that is a 11.6 as a sublayer, and a 5, that is a mu by phi by root gl. Those two are the non-dimensional factors here for this particular case. Now, to justify that, how come they are? Okay, so if you go for that, then if you go for the changes constant. Changes constant, what is that? In the equation, phi is equals to c root mi. C is the changes constant. So if you go for changes constant, c will be equals to phi divided by root of m into I. Phi is having unit as a meter per second. Okay, then phi is equals to root mi, that is it is hydraulic radius. Okay, r is equals to a by p, area by perimeter. Means a by p, area will have the unit as a meter square and perimeter will have the unit as a meter, means meter square by meter will have the unit as a meter. Okay, and I, that is a slope will not have any sort of the unit, means meter per second by root m will be there. Means this is not a non-dimensional parameter. Yala काय असणार, unit असणार, there will be a some unit. Means the first one, changes constant, is not a non-dimensional parameter. Then in the laminar sublayer thickness, delta star, okay, in a delta star, we used to denote the delta dash as a delta dash is equals to 11.6 into mu divided by a phi star. Whereas this mu is nothing but the kinematic viscosity and phi star is nothing but the shear velocity. Okay, as 11.6 is a constant. Only 11.6 as a sublayer thickness, as a sublayer, which are measure of sublayer, means 11.6 if you are talking about, it is a non-dimensional, it is a digit, it is a number, it means it is a non-dimensional one. It means we can say that this one is a one of the non-dimensional parameter. Then the next one, that is a h by n square d square, which is employed in comparing the performance of the pumps. So what is that? If you go for the dimension of that, that is a h divided by n square. I would have to go for here in h divided by n square d square. So h is having h is nothing but the head. Head is having the unit as a meter. Clear? N square, that is a rad per second, revolutions per second, or revolution per minute we can say, means it will be rad per second, means rad square per second square. I would like to go for rad per second square in the unit form firstly, and d will have the unit as a meter, that is a meter square. So it will be how we'll have the unit as a meter upon 1 by second square. So I would have to take the second square in the numerator, meter per second square upon a meter square. So meter square and meter gets cancelled. It is having the unit as a second square upon meter. Means this is also not a non-dimensional. This is also not a non-dimensional. याला काय झालं युनिट मिळालं म्हणजे हा नॉन डायमेन्शनल नाहीये. Then the next one is q square by d raised to 5. I would like to go for here q square divided by d raised to 5. Q is having unit as a meter cube per second, isn't it? Discharge unit काय आहे मीटर क्यूब पर सेकंड आहे. सो मीटर क्यूब पर सेकंड याचा स्क्वेअर आहे रेस टू 2 अपॉन d raised to 5. D is nothing but the having the diameter. So diameter is having unit as a meter. So meter raised to 5. So if you simplify it, we will have meter cube. Okay. Raised to 2 is there. So what will be the unit for the meter? Power of the meter क्या रहेगा मीटर का पावर? 3 रहेगा 9 रहेगा या 6 रहेगा? मीटर क्यूब पर सेकेंड ब्रैकेट स्क्वायर इज देयर. व्हाट विल बी द पावर ऑफ द मीटर? m का पावर कितना आएगा?
6.
6. Okay, m raised to 6 upon second square into meter raised to 5. So cancel क्या होगा? Meter raised to 6 and meter raised to 5 means it will have 1 upon a second square into a meter, we can say. Okay, it means it will have the unit as, sorry, meter will be in a numerator, means it will have the dimension as a length and t raised to minus 2, means it is also not a non-dimensional parameter. But if you go for the last one, that is a phi by root gl, directly we are knowing that phi by root gl is a Reynolds number. It is a non-dimensional, or we will go for its a dimension also. Phi is having unit as a meter upon root gl. G is a acceleration due to gravity. It is having unit as a meter per second into length is having unit as a, sorry, meter per second square. Acceleration hai, and length is having unit as a meter. If you simplify it, we will have meter upon root of meter into meter as a meter square upon a second square. It is under root. So if you take the square root, then we will have meter upon velocity is having unit as a meter per second. No, sorry. So velocity is having unit as a meter per second. So meter per second, meter per second. So if you take the square root of the meter square per second square, it will be meter per second, and it gets cancels. Means it becomes a non-dimensional group. It means the correct non-option is a, which is nothing but the B and a, sorry, a second and the fifth option. That is 11.6 and the phi or the u divided by root of a GL. This is about the question which was asked in a ESE 2017. Then if there exists another anything else than that, then I would like to go for that one also. Just a minute. Another one is there that was related to the release method. Okay, they had given us the question as that. It was asked in 1998. The question is like this: a release method of a dimensional analysis. In a release method of dimensional analysis, the dependent variable is written as the function of exponential terms of the independent variables. That is a reason also they had given us. It is in a release method, when the number of independent variables exceeds 3, the exponents of non-repeating variables are expressed as the exponents of the repeating variables. Okay, then the options they had given us, both A and R are true. They have given assertions. Okay, just a minute. I would like to go for first one is the first option A. Assertion they had given as A and a reason given as R. So assertion I would like to go for reading firstly. In release method, of a dimensional analysis, the dependent variable is written as the function of exponential terms of the independent variables. Reason are they have given. In a release method, when the number of dependent variables exceeds 3, the exponents of non-repeating variables are expressed as the exponents of the repeating variables. And options are both A and R true, and R is the correct explaining of A. Second option is both A and R are true. R is not correct explanation of A. Then third option is A is a true but R is false, and last option is A is false but R is a true. Okay, so correct option here is the option B, that is both A and R are true. Both are correct one. That is in a release method of dimension analysis, the dependent variables is written as the functions of the exponential terms of the independent variables. And the reason which is given to that, that is in a release method, when the number of independent variables exceeds the 3, the exponents of non-repeating variables are expressed as the exponents of repeating variables. Both are true one, but the reason R is not explaining, not giving the correct explanation of the assertion A. Okay, this is about the explanation for the question which was asked there in the ESE of 1998. That will be the now after this basics of the dimensional analysis, Buckingham-Pi theorem and all those things. Now the next most important part which we are going to start or discuss about from the examination point of view of the gate and all those things, it is about the non-dimensional numbers and their significance. So what are those non-dimensional numbers and where they are used, or what is their significance? That part we are going to discuss now, that to be in a detail. Okay, so non-dimensional numbers are those numbers they doesn't have any unit. If they don't have any unit, it means that they will not have any sort of the dimension. As unit is not there, it means that they will not be have any sort of the dimension also. So how they have formed? So all the non-dimensional numbers, those are involved in a fluid flow. Those are formed by considering the various forces those are acting on the flowing fluid. Those forces I would like to go for summarizing. Firstly, there is inertia force is there, viscous force is there, gravity force is there, pressure force is there, surface tension force is there, and elastic force is there. So by considering those 6 major forces, those non-dimensional parameters, those are mostly used in a dimensional analysis are derived. And for all those non-dimensional parameters, the one of the force is a basic one, that is a inertia force. Because whenever there occurs a fluid flow, or whenever there is a flow, then in that case there exists a inertia. It means whenever there is a flow, in that case there will be the movement of particles. As movement of the particles is there, it means that in that case whole mass is going to change its position from one place to another position. That liquid mass we can consider, or water which is flowing through the channel. And as all the molecules will not have the same velocity for the open channel flow, then in that case we used to say that the mass into velocity, the product, that is a momentum, that momentum of each and every particle will be the different one, isn't it? Or if that flow is having exactly a laminar case, in that case the momentum of all the particles will be the same one. But as if the velocity is going to change, in that case usually it's a momentum is going to play a main role therein. And that due to that, the flow, due to that flowing fluid we can say, or due to the motion, once that particle will be in the motion, the particle is going to offer a resistance टू चेंज इट्स मोशन, यानी कि जो भी उसका वेलोसिटी बाद में चेंज होने वाला है उसको अपोज करेगा, और जो अपोज करने वाला जो फोर्स रहता है उसको हम इनर्शिया फोर्स बोलते हैं। यानी कि जब भी फ्लोइंग फ्लूइड रहेगा तब तक क्या आएगा, इनर्शिया फोर्स हैज टू बी देयर। सो विद रिस्पेक्ट टू द इनर्शिया फोर्स all the numbers are derived. So first number which we are going to discuss here, that is a Proud number. Okay, so Proud number, before that we'll go for the Reynolds number firstly, because it is firstly derived therein. Okay, so Reynolds number or a Proud number, whatever it may be, it doesn't matter that which number you are going to have or we are going to study over there. Okay, so firstly we'll go for the Reynolds number. So Reynolds number, we are knowing that Re, it is a ratio of inertia force to the viscous force. So inertia force is denoted as Fi and viscous force is denoted as Fp. So inertia force, we are knowing about inertia is nothing but the mass into the acceleration. Okay, that is a rho a v square. In general, we used to write inertia force as rho a v square, where rho is the density of the flowing fluid, area of the cross section or water area we can say, or flowing area we can say, cross section area we can say, and the v is the velocity of the flow. And whenever we are talking about the viscous force, now the viscous force is related to the shear stress. It is a product of a shear stress and area. So shear stress is nothing but the tau, okay, into the area as a. Then this tau, we are knowing that as per the Newton's law of the viscosity, that is a tau is equals to mu into du by dy. U is nothing but the velocity, whereas the y is nothing but the one of the parameter related to depth we can say. It means I would like to go for directly replacing that density area into velocity, that is a rho a v square inertia force, and instead of the tau now I would like to go for mu du by dy, and mu into du by dy, though we are writing here in, so mu as it is, du by dy is there in, so u instead of the u, that is a velocity, I would like to write here as a v, and y as a depth. Okay, so I'd like to consider here that directly a parameter as a length for that, into the area a will be there. So area will get cancelled over here, one of the area will get cancelled, then velocity, one of the velocity will get cancelled, and ultimately we will get the Reynolds number as rho phi l डिवाइडेड बाय al ऊपर जाएगा, रो एक फी गया, एक फी रहेगा, रो वी एल डिवाइडेड बाय म्यू रहेगा. Okay, that is for a dynamic viscosity. Then if you consider the kinematic viscosity, then we used to have the formula as rho phi d by mu directly, phi d, phi into d divided by nu we can write, because we are knowing that relation between the dynamic and kinematic viscosity as mu is equals to rho, sorry, mu by rho, or mu is equals to nu into rho we can say. From this relation we used to get directly phi d by nu or phi into l by nu. Whenever we are considering the canals, then in that case we used to consider the parameter as a length. For the pipes and all those things, we used to consider the parameter as a depth, d, or the diameter as a d we used to consider. So that is rho vd by mu or rho vl by mu, that is a Reynolds number. Then talking about the significance, it is where it is used. So Reynolds number is used wherever the dominating force along with the inertia force is an viscous force. Whenever the viscous force is a dominating force along with the inertia force, then in that case we used to prefer the Reynolds law. We used to consider the Reynolds number we can say. It means the flow inside the flow of the flowing fluids where the viscosity is the major one, then in that case we have to consider the Reynolds number or the Reynolds law. Then after that, the second law which we are going to consider here, that is a Proud law, or sorry, Proud number. What is that Proud number? Proud number is a ratio of square root of inertia force to the viscous force. Square root of inertia force to the viscous force. Believe me that only one of the number, that is the Reynolds number, is that which is having a straightforward ratio. It is not having any square root. But for other remaining numbers, we have a square root. Okay, so for Proud number, it is the ratio of the square root of inertia force to the viscous force. So inertia force, once again we are knowing, that is a rho v into d. Just now we have written therein. So directly I would like to go for here rho a v square, that is a inertia force divided by the gravity force. So now gravity force is nothing but the force due to the gravity, that is a g we can, that is a density into volume into g, isn't it? It is a rho phi into g, density into volume. So density into the volume I would like to split as an area into the length, as we are considering for the open channel flow or the flow through the pipe, sorry, open under flow under gravity, means that will be related to the open channel, into the g whole terms will be the under root, and after cancelling the terms we used to get the ratio as V divided by root of L into the G. This is nothing but our Proud number, V divided by root of LG, length or depth we can. This is about the Proud number. Now the so significance where it is used. So wherever the dominating force is a gravitational force along with the inertia force, then in that case we have to prefer the Proud number. Means जब भी होने वाला flow आपका under gravity रहेगा without any additional force, then in that case we have to go for the Proud's number. That is the problems involving the dominance of the gravity force, that is a open channel flow, flow over the weir, flow over the notches, etc. In such things we have to consider the Proud number, or we have to prefer the Proud number. This is about the second number, that is a Proud number. Third one, that is Euler's number. Euler number we will talk about. It is denoted by a EU. It is a ratio of the square root of inertia force to the pressure force. It is a ratio of square root of inertia force to the pressure force. Inertia force, once again, we are knowing that is a rho A V square. Okay, area I would like to go for rho A V square. Inertia force divided by a pressure force, that is a intensity of a pressure into area, that is a P into A we can. Okay, that is a P into A. Okay, and after simplifying it, it is a under root. After simplifying it, we used to get the Euler number, or the Euler number as rho V square divided by a P. And in the, again, if you go for the simplification, then in that case we used to get the phi as outside, phi divided by a root of P by rho. This is our Euler number or Euler number. Significance, it is used or it is employed wherever we are having dominating force as a pressure force along with the inertia force. That is, wherever pressure force is existing or a pressure gradient is existing, in that case we have to prefer the Euler number. That is for the flow through the pipes, because their force is a pressure, that flow is under pressure. Then water hammer, it is also due to the water pressure. Then flow through the orifice, flow through the mouthpieces, flow through under the sluice gates. In all those cases, the pressure force is to involve, and under such conditions, we have to prefer the Euler number. The next number, non-dimensional number, is the match number. So match number is the fourth one. It is a ratio of square root of inertia force to the elastic force. Inertia force, once again, rho A V square, and the elastic force is due to the elastic stress. Okay, elastic stress, that is a bulk modulus of elasticity into the area, that is a K into A. Bulk modulus of elasticity into the area, it gives us a directly elastic force. After simplifying all those things, we used to get the ratio as rho V square divided by K. Area gets cancels here. What you see is rho V square by K. And if you take the velocity as a only parameter in the numerator, then we used to get a V divided by a root of K upon rho. This is about the match number. Here, if you consider K by rho, see this K by rho indicates the velocity of the sound in a flowing fluid. Velocity of the sound in a flowing fluid. Okay, so number of the times it is denoted as a C also. Okay, so the applications or the significance of the match number, we can say it is applicable wherever the elastic force is a dominating force along with the inertia force. Now where that bulk modulus of elasticity or the elastic force is involved, so it is involved in a compressible fluid flow, we can say, where the object is going to object will be get compressed or stressed. That is, problems involving the dominating elastic force, that is a compressible flow at a high velocities. Compressible flow at a high velocities. That is, for example, if you go for motion of the missiles, high velocity is to there. Then projectiles, then flow through the pipes at a high velocity. Those are the some of the examples of the phenomenons or the flowing fluids, we can say, or the flowing objects, we can say, at which or for which we are preparing a match number. Then the next number is the Weber number. Weber number is nothing but the ratio of, it is the ratio of inertia force to the surface tension force. यानी कि जहां जहां पे surface tension force आएगा वहां वहां पे हमें क्या करना चाहिए, we must be prefer, or we must prefer to the Weber number. So what is that now? In the square root inertia force, once again rho a v square divided by surface tension force. We are knowing it is due to the surface tension. So surface tension into the length, it gives us a surface tension force. It is a sigma we used to denote by a surface tension into the length over which it is acting, that is L. If you consider the area is L square, then L, one of the L gets cancels, and we used to get the ratio as rho L v square divided by a sigma. That is a surface tension. And after simplifying, we used to get in terms of the velocity as v divided by the square root of sigma upon rho L. This is about the Weber's number, which is the ratio of inertia force and a surface tension force that will be under root. So where it is used now? So as a surface tension phenomenon is there, it means that if you are considering a raindrop, okay, sorry, if you are considering any surface tension phenomenon, that is a capillary rise, capillary fall, in all those cases the surface tension plays a vital role. It is an important role. It means for such cases, there is a capillary movement of the water in the soils or in the capillary tube, we can say. In such cases, we needs to go for the application of the Weber's number, or we have to go for refers to the Weber number. Along with that, whenever we are going for the liquid atomization, in such cases also we need to go for the Weber number. This is about the non-dimensional numbers and their significance. Now we'll go for the questions those were asked in the gate related to those numbers and end semester, that is ESE, IES. So the first question which I have considered over here, it was asked in gate 2013, which says that the group 1 contains here the first group, that is a group 1. It indicates the dimensionless parameters, and group 2 contains the ratios, and the group 2 contains the ratios. What we have to do, we have to match the things. Okay, so this is the given pair, group 1 and group 2. Group 1, match number, Reynolds number, Weber number, Prout number. Group 2 is given us as an the related things, ratio of inertia force to the gravitational force, ratio of fluid velocity and velocity of a sound, then ratio of inertia force and viscous force, ratio of inertia force and a surface tension force. We have to match those ratios with related to the particular numbers. Now, if you go for the first one, that is a match number. Okay, first one, if you go for that is a match number, then we are knowing that the match number is a ratio of inertia force to the elastic force. Okay, match number is a ratio of the inertia force to the elastic force, and just now we have derived that equation for the match number, that is a phi divided by root of k rho. I'd like to go for equation also, phi divided by ratio of square root of k by rho. And just now I have mentioned there, k by rho is nothing but the velocity of a sound in a flowing fluid. Velocity of a sound in a fluid. Okay, velocity of a sound in a fluid. It means that phi by k rho we can. So we have to select the proper option from the group 2 now related to the match number. So which is that? It is a ratio of now, inertia force to the, which option is correct? 1, 2, 3, up 4, 1. For
3.
2.
For the match number, match number is a ratio of inertia force to the elastic force, and after simplifying it, we used to get phi divided by k upon rho, and k by rho is nothing but the velocity of a sound in a fluid. So which is correct option?
2.
2.
It's a 2. So I'd like to go for directly here as a 2. Then नेक्स्ट वन, इट इज रेनॉल्ड्स नंबर. रेनॉल्ड्स नंबर किसका किसका रेशो होता है, कौन से फोर्सेस का रेशो रहता है?
Option 3.
ऑप्शन
3.
3. I would like to go for directly. Good. Then Weber number.
1.
Weber number.
4.
Weber number किसका रेशो है? Inertia force to the surface tension force. So that will be a fourth one. And Proud number will be ultimately the first one. This question was asked in a ESE. Okay. For in 2013 they have asked. 2013 for Indian Engineering Services. Options I would like to go for here. I had options. So now we have to select now appropriate option amongst the A, B, C, D. Which one is correct now?
Option C.
Option C.
C. P to the 2, exactly P to the 2, Q to the 3, Q to the 3, correct. R to the 4, R to the 4, and yes to the 1. It means that option C is the correct option for this particular question. Understood about this one?
Yes, sir.
Okay. Then on the same lines, in the GATE examination also the question was asked. This was related to the GATE 2013. It was related to the GATE 2013. In the ESE, just a minute, in ESE the question is also there. I have to just check the in which year they have asked. Yeah, in 1995, but just they have changed the in 1995, then in 2006. Okay, again 2 times till time they have asked on this particular thing. What they asked in a 1995, first I would like to go for same match is there. First one is the match number, second is a Thoma number which you have not considered over here, third one is the Reynolds number and a Proud number. Second option only I would like to go for a changing here, it is a Thoma number. Okay, options they are, first option was waves in an ocean, means directly they have asked for the significance. First option is waves in a ocean. Second option is launching of rockets. Rocket, I just written launching rockets. Third one is cavitation phenomenon. Cavitation phenomenon. And last option is motion of submarine. Motion of submarines. Now out of those, now we have to match here. We have to match. I would like to go for the black color now. Okay, only changes that instead of the Reynolds number is there as option C. Just a minute, I would have to change here. This is a Reynolds number RE. Here second option is a Thoma number and last option is a Weber's number, WE. I would like to go for match number. First one, second one is a Thoma number, third one is a Reynolds number, and fourth one is a Weber's number. Now we have to match the pairs. Options, these options are also the different one. I would like to go for those options, but at the last I would like to go for. So firstly we have to match them. How you will go for? Regarding the simplest one we'll go for firstly. Reynolds number. Reynolds number किसको मैच करेगा रे?
Motion of submarine.
Motions of a
Submarine.
just check it. I would have to go for options. Firstly मैं option लिखता हूँ यहाँ पे. Small a, b, I would have to go for here. A, B, C, and D, and they are given us as like this: A, those are the, they have denoted as A, B, C, D. Capital A, capital B, capital C, and capital D. And there as it is 1, 2, 3, 4. A, B, C, and D. Codes they दिलेले आहेत A, B, C, D असं. Here they have written as 1 options they are given 1, 3, 5, 2. A हा option दिलेला आहे. B is a 3, 2, 4, 1. C option is 2, 3, 4. So 2, 3, 5, 4. 2, 3, 5, 4. And last option is 2, 1, 3, 4. 2, 1, 3, 4. Here we have to consider as a 4. Here this is a 4. But let me write here. This is 4. Okay. So now from this we have to select the correct option. So firstly I would like to go for the simplest one, Reynolds number. Reynolds number किसको correct करेगा रे? Motion of a submarine. किसी ने तो बोला था, isn't it? So Reynolds number connecting to the submarines. It is a motion of a submarine. Okay, means we got the first one. Reynolds number we got. Then match number will go for. Match number किसको correct करेगा रे? Match number में क्या आता है? Related to the match number. It was match number is the ratio of inertia force to the elastic force. Okay, and in the previous slide just now while explaining the things I have explained that it is a ratio of the phi by k by rho. Just now we explained, and it is related to the compression. It is a high velocities, the motion of rocket, that is a rocket. So match number I would like to consider here relating to the launching of a rocket because it is involving a high velocity and it will be compressed one. Okay, then two are over. Which one? A and C we deal with. Thoma number will wait for. Last one will go for now. Weber's number. Weber number किसका रेशियो है? Inertia to the surface tension है. Inertia to the surface tension है. Okay, so Weber's number. Which phenomenon it will relate?
Option 1, waves in ocean. Capillary.
Which one?
Option 1.
Weber's number.
Option, ocean.
Waves in oceans. These are red options we have to consider. Huh? Waves in oceans, launching of rocket, cavitation phenomenon, motion of submarines. Motion of submarine is over for the Reynolds number. Okay.
Cavitation.
बोला 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 बोला. मोशन ऑफ सबमराइन आपण लिहिलेलं आहे. ओके, हा कॅपिलरी फ्लो इन अ सॉइल आपण लिहायचं. माझा एक ऑप्शन लिहायचं राहिलं रे. जस्ट मिनिट. वन ऑफ द ऑप्शन आय फॉरगॉटन टू राइट ओव्हर हियर. दॅट इज मी इथं लिहितो. दिस इज द फोर्थ वन ऑप्शन. Fourth option I would like to go for. This is a fifth one. That is a motion of submarine. That is the correct one that we had written. Fourth option I have forgotten. That is a capillary flow in a soil. Capillary flow in a soil. Capillary flow के लिए कौन सा आता है number? Which number we used to have for capillary flow? Weber number we did wrong with. We did wrong with the Weber number. वेबर नंबर कुठे येतो रे? कॅपिलरी मुवमेंटला वेबर नंबर येतो, बरोबर आहे का? सो वेबर नंबर, सो वेबर नंबर विल बी रिलेटेड टू द फोर्थ वन ना. सो दिस इज द फोर्थ. वेबर नंबर इज डी. सो इट विल बी रिलेटिंग टू द फोर्थ ऑप्शन. दैट इज आई हैव टू राइट हियर ओनली. दैट इज अ कैपिलरी. It is a capillary. Now what else remain? The Thoma number is remain. Okay, so Thomson number, that is Thoma number is related to the cavitation. Is related to the cavitation. So this is about the solution for the this ESE examination 1995. Then the next one, next they have asked in ESE 2006. I will have to go for next slide so that idea. Just a minute. जल्दी विचार करें. The next question which was asked in a ESE, it was in a 2006. ESE 2006. They are given us the list 1 and list 2. In list 1, they are given the non-dimensional numbers: Reynolds number, Proud number, Match number, and Weber's number. And in list 2, they are given us the options as like: first one, formation of liquid droplet; second option, high speed flow of a gas; third option is flow in a closed conduits; and fourth option is a sloping interface exists between the fluids of a different densities. And what they asked: match the list 1 with the list 2 and select the correct answer using the codes given below in the lists. So options are A, B, C, D likewise, and we have to select the proper or the correct option. So what is the correct option? I'm firstly asking about correct option. Is it A, is it B, is it C, or is it D?
Option D.
Option D. As per option D, A is related to the 2, means Reynolds number is related to the high speed flow of a gas. Is it like that? I don't feel so. Reynolds number is not related to the high speed flow of a gas. Reynolds number, if we are talking about, then Reynolds number is related to the viscosity, isn't it? Reynolds number is related to the viscosity, means viscous force. So viscous force यहाँ पे कौन से ऑप्शन में है रे?
3.
No, sorry. Reynolds number is related to the inertia of the viscous force. Exactly. Huh. In a 3, so closed conduits we can say. So it will be for a 3 RE. Then the Proud's number. Proud number कौन से force आते हैं उसमें? Inertia force to the
Gravity.
Gravity force.
Gravity force. Okay. It means that there will be the sloping interface between fluids of a different densities, because the fluids, if you are going to if you are going to have two fluids of different densities, and if you are going to put them on a sloping interface, then they are going to start the moving. But the fluid which is having less density will move faster than that of, okay. So when the two fluids are going to flow over a slanting edge or a sloping surface, then obviously the fluid which is having a less density will move faster than that of the fluid having a high density. It means this will be get matched to the fourth option. Okay, B will be get matched to the fourth one. Then C, that is a match number. Match number, we are knowing about the match number. It is related to the elastic force. Okay, and after that it is related to the high velocities. It means the match number will be get related to the high speed flow of a gas, related to the high speed. So it is related to the high speed flow of a gas. And lastly, the Weber's number. So Weber number, we are knowing that it is the inertia to the surface tension, means a formation of a liquid droplet is due to the phenomenon of a surface tension. So it will be get matched to the first one. So now we have to find out the pairs. A is related to the fourth one. I would like to go for A as a 4, B as a sorry. A as a
A3A.
A3, sorry. A as a 3, B as a 4, C as a 1. Barabar ka?
2.
C as a 2, exactly. C as a 2, and D is matching with a
1.
1. So which option is correct now?
First. Option A.
Option A is the correct one. That is a 3, 4, 2, 1. 3, 4, 2, 1. This is about the solution for this example. Okay, today we'll stop here, and in the next lecture we'll go for the next part of the dimensional analysis and model analysis, similitude and geometric similarities, etc. Okay, thank you.